Hello everyone. In this video, I'm going to discuss about a sorting algorithm called bubble sort. Bubble sort. So, in the bubble sort, first I'll discuss about advantage of bubble sort. Then we'll discuss about disadvantage. And then we'll write the code, and code will be in Java. And then we'll see the time complexity and space complexity, and at last we'll dry run the code which we have written. So I'll just start with advantages. So the first advantage which I will say is easy to understand and implement. Then no additional space is required when we use bubble sort for sorting. Space, or you can say memory. No additional memory is required, and bubble sort is a stable sorting algorithm. So what is a stable sorting algorithm? It means that elements with the same key value maintain their relative order in the sorted array. So, so when we have a two elements having the same value in unsorted array, so when we sort that array with using bubble sort, it will maintain the relative order of that element. So that is what a stable sorting algorithm means. Next, disadvantage. Disadvantage. So the first disadvantage which I see in bubble sort is the time complexity. It takes order of n square time. So when you have a very large data set, it might be slow. It may work very good when we have a very less data set, but when we have a huge amount of data that we need to sort, if we use bubble sort at that point of time, it might be slow. Then bubble sort is a comparison based sorting algorithm. Comparison based sorting algorithm, which means that it requires a comparison operator to determine the relative order of elements in the given unsorted array. So these are the disadvantages. And now next, third, I'll discuss the code, like how we'll write the code for bubble sort in Java. So the concept is same, uh, but I will write the code in Java. So let's write the code. We'll just make a method public void bubble sort, which will take a array. Let's take here, and first of all I'll just calculate the length of the array, and I'll store it in a value called n. Then we'll start a loop int I equal to 0, I less than n, which will go to the, we have calculated the value of n in the first line, I plus plus. Then we'll have another loop which will run from j equal to I plus 1 and j less than n, j plus plus. And then we'll compare the value of array of I is greater than array of j, then we'll do the swapping. So for swapping, we'll take a temporary variable called temp. We will take the array of I into temp and then array of I equal to, we'll just copy the value of array of j and then array of j equal to temp. Then we'll close the if SOR and then external SOR and then finally method will close. So this is the code. Now we'll just take a example array and we'll do the dry run, or we can even discuss complexity. So here the first loop will run for all the element and the second will also run from the next element to the last element. So there are two for loop. So time complexity is order of n square and space complexity is order of 1, since we are not taking any additional space when we are doing the sorting. So let's take an example. So I will take a array integer array where I'll take some random value. I am taking 5, 2, 7, 1 and let's take 12. So now we'll do the dry run. So for the first pass, when I is equal to 0, the value of j is equal to 1, since second loop is running I plus 1. So the value of I is 0 plus 1 is 1. So let's take the array 5, 2, 7, 1, 12. We'll do the indexing 0, 1, 2, 3, 4. So now we are doing array of I is greater than array of j, then we will do the swap. Since it is a comparison based sorting algorithm, we compare the value of, so that we can do the swapping. So when we array of I is greater than array of j, here we will compare, and array of I is greater because 5 is greater than 2, so we will do the swapping. So then now the array will become 2, 5, 7, 1, 12. Okay. Now again array of I, now the value of j will become 2 and I is 0. So now we will compare 2 and 7. So 2 is not greater than 7, so we will not do any swapping. Now the j value becomes 3. Now so 2 is greater than 1, so again we will swap the value. Now the array will become 1, 5, 7, 2, 12. Next, j value will be 4. So array of 0, which is 1, is not greater than 12. So we will not do any swapping. And value of j will be 5, and since it is greater than length, so it will come out of inner loop. So now, so this was complete first pass. After first pass, the array will become this. So see, once my first pass is completed, here I can see that the smallest element is in the first place, which is sorted. So in every pass, one element will be sorted. So we have completed our first pass. So we got the smallest one element in the array. Similarly, when I value is 1, j will be 2. So now it will I this is 0, this is 1, this is 2, this is 3, this is 4, and I is equal to 1. So now it will compare from 5 to 7. So it is not greater, so it will not swap. Now 5 will compare with 2. So 5 is greater than 2. So now array will become 1. Will swap the 5 and 2. So 2 here, 7, 5, 12. Now we'll compare the next value, which is 12. So 2 is not greater than 12. So we will not swap. So after second pass is completed, we see my second largest element came in the second place. So now after two pass, my first two element is in the sorted order. Similarly, when I is equal to 2 and j is equal to 3, so after second pass is completed, my array is 1, 2, 7, 5, 12. This is 0, 1, 2, 3, 4. Now I value is 2 and j is 3. So array of 2, which is 7, is greater than 5. So we'll do the swapping. So now array will become 1, 2, 5, 7, 12. Next, 5 is greater than 12. No. So we'll not do the swapping. So after third pass, if you see, my third element is in the correct order. So 1, 2, 5, 7, 5. Similarly, when I is equal to 3 and j will be 4. So here in this case, if we do keep going, we'll not swap any element because we got that sorted element. So the condition will not be satisfied anytime. So we will not do any swapping, just we'll be running the loop. So once my both the loop finishes, the final array which we will get is 1, 2, 5, 7, 12. We see this is sorted one. So it is in ascending order. So the output which we got is 1, 2, 5, 7 and 12, and this is the right output which was expected when we write our code this. So we are able to write the code successfully, and when we dry run our code, it worked. So that's all guys. We'll see in the next video. Thanks for watching. Bye bye.